What's up? Welcome back. Today we're working on my x86 operating system titled Stream OS. This is an operating system that we've been developing on Stream for fun, I guess, right? Like we're just trying to see, well, what's going to happen? How do we get to a point where our operating system can run code that we're interested in running, essentially, right? And we're kind of just like bumbling our way through it until we get to somewhere interesting. So right now what we have is we've got a little demo that we can run that like boots up a virtual machine with our kernel running in it. We have like this game that we run. We can like control this like brick breaker paddle with the mouse, which means that we have like a USB stack because it's a USB mouse that's and we've got like a graphics stack is like we're running this to the screen, which we're in this example QEMU is emulating like a VGA monitor, and so like if this is a real thing, like a real computer, you would see this on the real computer. This is what you'd see on the screen. We have like logging going to the serial console, so from the perspective of the operating system, it thinks that there's like a serial port on the back of the machine, and when it writes that serial port, it gets forwarded to standard input output here. We have like this like little web server that we run, so if we wanted to start like using this to like run some sort of like web project, we could start doing that. And if we like start punching stuff in here, we get data back, which proves that like the operating system is seeing something, right? Like he's like getting the data and sending it back. And what we've been working on for the past few days is running Doom on the OS. So we pulled in this like project Doom generic. And what this guy is he's like a C program. I guess library is maybe like a more sane definition for what this is. And you basically, the promise is you implement these few functions. And once you do that, you have basically a working Doom game. The problem with this is that the like library assumes that you have like libc, where libc is like basically all of the implementations for like the stuff that you expect to get when you include stuff in C, right? So you like include standard IO to get printf, and you include like math to get floating absolute number, and you include like, I don't know, there's like, there's just lots of stuff in here, right? Like if you want to interact with the operating system to like get the time, or like open a network socket, or like get input from the keyboard, right? All of that stuff has to go through the operating system, and we haven't implemented any of that. So what we're doing is we've, hold on, let me go on the right branch, because the demo is on the master branch, and what we've been working on is on the Doom branch. So if I pull this guy in, what we've been doing is we've basically got to the point where we can compile, and we did that by iterating through every function. Like we just looked for every undefined function, and we implemented it in C by copy-pasting the definition and just basically crashing the program. And now when we run our Doom program, or sorry, when we run our operating system, it tries to boot up Doom, and it might hit one of these functions and go like, what the fuck? Like, that's not implemented, and our OS crashes. So just give it a sec to compile. Beep, boop, beep, boop. And yeah, see, so here we've got like some of the like logs from Doom are running. It's doing something, and now we're getting to the point where it says like, well, this ftell function is not implemented, and so we're just like moving through crash by crash, trying to implement the functions that it needs. Yeah. So what we did last stream was we got to the point where it started trying to like load a WAD. So a WAD in Doom, I think it stands for like, where's all the data? Or something silly like that. And it's basically like, you have like the open source Doom engine, but you don't have like Doom, the game is like this like closed source thing. And so the data for Doom is like packaged separately from the engine. And so what we've done is we've pulled in this like free Doom WAD, which is basically like an open source free software Doom implementation. It's not like the same game, but it's got like all of the same things that you would have in a Doom game. Like you've got the shotgun, you got like some monsters, but they're not like the same monsters necessarily, but they behave very similarly. Anyways, so we've like injected that WAD into our like fake file system that we're making. So in our, let's see, in our libc implementation, when someone calls fopen, that turns into a how do I say this? We look at our like fake file system, which we're just kind of storing in static memory, that's just like backed by like a hash map of paths to files. And these files are just like buckets of bytes, right? So we have like pre-injected this doom wad into our operating system. And so when it tries to call fopen, it looks as it says, oh, is there a file called free doom wad, free doom1.wad? And we like give it back to them. And all we've done is like said, we are successfully able to open that file, but we haven't ever actually implemented any like reading or writing to it. And so that's kind of where we're at now is it's crashing saying ftell is unimplemented, which is basically trying to say like, well, let's see, man ftell. I actually don't know what this does yet. Ftell obtains the current value of the file position indicator for the stream pointed to by the stream. So I guess it gets like the position in the file. Maybe? Yeah. So we have to start implementing like basically how do we read a file, not just check if it exists. And so that's where we're starting today. So let's say that we are 6 minutes into stream-ish, and we are now working on implementing ftell. Okay. So what is our like file abstraction right now? We have this like fake file who's like a mutex locked vector of data. And to implement ftell, we need to know like where have we read to in the file. Sorry, I'm noticing that I think my camera's a little bit delayed and that's really pissing me off. So just give me a second to like see if I can fix that. Oh, that made it worse. For sure. One sec. Video capture device. Oh, the camera's just like totally fucked. One sec. Let me just go unplug, replug 1 minute. Alright, did anything go horribly wrong? No, we're still here to some extent. Video capture device. And maybe we're back. Holy shit, that looks like garbage. Okay, we go to motion JPEG. Aperture priority mode. Yeah, that's probably okay. We put this guy back in the corner. And we kind of trim him down a little. Sorry about that. Okay. Are we back? Yeah, that's all right. There's like the exposure time's kind of fucked up. Can I lower exposure time? Hold on. We're almost there. Oh, that's really bad. I don't like this. Okay. We're just gonna delete the camera here because I don't want to spend too much time on this. Sorry about that. And we will just have a cameraless stream today. Okay, so sorry, where were we? Looking at ftell. Yeah, so we need not only do we need like the data that's in the file, but we also need to like track where we have been reading in the file. So this is actually going to be more like a struct. And I guess the thing that we store on our file system, he doesn't actually have to keep track of the position, right? Because you could have like multiple files that are both reading the same data, and they could have like different cursor positions. So really we should have like struct file cursor or something. And he could have like his position in the file, as well as a reference to the data, which he's going to have as a spin lock vec u8. And I guess we have to attach a lifetime to this data, which is pretty reasonable. Okay, so now our file pointer that we return, like in C, let's see if we, where do I want to check this? I guess in stdlib, where does fopen come from? Struct file here. Okay, so fopen returns like a pointer to this file structure. And so from the C's perspective, they see like a struct file and they don't know what it is. They just know that they have a pointer to it and they have to pass it back to these other functions that take in file stars. And so what we've done is in Rust, where we're implementing our standard library, we have an enum file that we are using as the implementation of this like opaque pointer. And so in here we have, well, our file has this pointer inside it, but we can instead say that he has a fake file inside. Oh, sorry, a file cursor inside. Our file cursor has a lifetime associated with him, which is annoying, so we'll just maybe say that he has to be static for now. And then we have to kind of do some juggling around to get that. So here we have a file that is a spinlock evacuate. And so now we have to convert that into a file cursor. So we'll say let cursor is file cursor with position of 0 is probably where he should start. And the data should be at, I guess, is a reference to this file. Like this. And then we'll say unimplemented below just to try to, I guess we'll just say some file cursor like this. And then we have the same thing here where I guess we'll make a little function. Function file to cursor. And what does he take in? He takes in a file, which is a fake file with static lifetime. And he returns a file cursor with static lifetime. And he just does this thing here. Sure, that seems reasonable. I guess he'll return actually our file type, which means here he has to say file cursor like this. Okay, so then we return some file to cursor, and we have to do this like and star file shit, I think. And then in this map over here, in this other case, we can do the same thing where we say file to cursor. Okay, so he's bitching about something. Let's see what he doesn't like. He expected box spinlock evacuate, found spinlock evacuate. That makes sense. So here we just replace this with spinlock evacuate because we're like not looking at the heap allocated pointer. We're not like trying to destruct that or anything. We're not trying to like handle lifetimes. That we're just trying to get a reference to this thing that we know is going to live forever. Which means that this guy I think can just come in like this. Webcam fail. Good evening. Yeah, unfortunately, struggling with the webcam, so it's off for today. Hopefully, we'll fix it tomorrow. Okay, what's he bitching about now? He doesn't like that I can't format the file cursor with debug. So we'll implement that real quick. Drive debug, just to fix that. I think that this is a reasonable thing to debug log, probably. I think that's fine. Okay, so here he's saying when we return this guy, we have lifetime issues. So because fake file system is not guaranteed to be static lifetime. So I wonder if I can just say this. If I say, hey, we're guaranteed to be static lifetime here, so the thing that you get out is guaranteed to be static lifetime. I think that actually might work. FS does not live long enough. So at 540. Interesting. So here we have that our locked thing returns a lifetime that is the same as file system, and file system should live forever. So that's kind of interesting. Let's take a look at this. Maybe when we work with mutexes like this, it can't work out. Interesting. I really thought that would work. Because file system, this guy is static lifetime, which means that the reference that we have in our spin lock guard should be static lifetime. Oh, hold on. In our spin lock guard, when we deref, we should return this thing of A, the lifetime of the thing inside. Lifetime may not live long enough. Interesting. So this lifetime, that when we deref this like spin lock guard thing, which is like a locked version of this thing behind like a mutex. What if I do this? He says that he can't live long enough. Does not necessarily outlive the lifetime A. Ah, fuck. Okay, so the problem is that like the thing inside does not live long enough, but it should, right? This guy should be guaranteed to live long enough because inner has a type mute t with like the lifetime A. And so when we deref, I would think that this should be able to live for lifetime A. Can I do this? Why doesn't it like that? Method was supposed to return data with lifetime A, but is returning data with lifetime 1. Yeah, interesting. I guess because self has a lifetime of 1. Alright. We'll just dodge this by doing some like bullshit. That's fine. I shouldn't have expected this to work, I guess. So I guess what I'll do here is I'll just do like some fucky wucky casting in here. So we'll just note this is a complete violation of lifetime rules that only works because we know that fake file system will always have a static lifetime. Okay. So we'll take in this thing, return the file, and here we just say file as const pointer to a spin lock thing. And then we say as static spin lock thing. Which we actually have to do with a dereference. So here we go. We star this, and we put this in unsafe. Oops. Which we'll do like here, I guess. I wonder if you can put an unsafe block here. I actually don't know if that's legal. Oh, it is. All right. Cool. So this allows us to like return something with a static lifetime, even though it's not static. And something will go horribly wrong in the future if that constraint is ever invalidated. But that's okay. I don't mind. I don't think it'll happen. Okay, so what were we doing again? We were trying to implement ftell. And ftell requires that we have a file cursor. And so now when we implement ftell, we can say that we get this function called ftell, we get the file in, and what comes out is, let's see, man ftell along, which I actually don't know how many bytes that is. x86 long bits. Is that a 64 U64? Oh. We can just check, of course. So gcc-o test.c. Oh, but this is on x64. Fuck. We need to test on x86. Long as I don't know. Well, how do we check this? How do we check this? I guess we'll just fucking print it in our main. Can we just say like print long size, and then in fake we'll say that that's a function that we support, print long size, and then on the C side of things we'll say void print long size void, and we'll just say the same thing. Okay. So I guess here, let's quickly just comment out that fake libs ftell shit that's gonna make everything not work right now, and we'll just cargo check, make sure that we compile, which is good, and we'll cargo run, and hopefully we see what the size of long is. I think it's like it's could be 32 or 64. I'm not sure. I guess on 32-bit, my guess it's 32 bits. I would guess that int and long happen to be the same size, and long would be 64 bits. Just a guess, though. So here, somewhere, we actually didn't print this because we crashed before we got to that part, so we'll go back to our main, and we'll just make sure that we swap these guys. Run this before we try to initialize the Doom shit. All right. Size of long is 4. Okay. I guess we could also just say core fi, I think C long. I think that I should have just done this from the start. Oops, we'll go in here. Core fi C long. Okay. So what do we do here? So we get the file and we say match file. And I guess it's match f, sorry. And if we get a file cursor, we just return cursor.pause. If we get file standard out, I don't know what we're supposed to do on standard out. Does someone tell us? Man 2 std out, man 3 std out, ftell, pause, like, I don't see anything obvious here telling me, oh, since files are wrapping buffer on Unix files, using the same underlying files may be using raw Unix file interface, that is functions like read and fseek. But that can produce unexpected results. I don't know how, let's see, std out ftell. Does someone tell us what it's supposed to do? Oh, they just returned -1. All right, that seems reasonable to me. Seems reasonable to me. Okay. And we'll say try into expect could not convert cursor position. And here, I guess we have to dereference this guy. And like this, maybe? Yeah, there we go. We take the reference, the dereference thing, and we check it. Okay. All right, so now if I cargo run, release, we should pass that ftell crash. Oh, instead we just don't compile, you know, as expected, because we have two definitions of ftell, the one that tries to crash our system and the one that we actually just implemented here. So we'll just look up ftell in here and just get rid of that guy. Get rid of him real quick. Give it a sec. Maybe I shouldn't build in release mode. I don't see it. There's no reason to do that right now. It just takes longer because you have to do like run optimizations and shit. If you don't optimize, your compiler has less work to do. Easy fix. Okay, so now he's saying fseek unimplemented. That's cool. So fseek. What kind of variable name is whence? Dude, I don't know if I've ever heard that word in my life. I guess that's like a noun for when, like the time something occurred, from place or source from which. Weird. Okay, whatever. Man, fseek. What's he supposed to do? Sets the file position indicator for the stream pointed by stream. The new position measured in bytes is obtained by adding offset bytes to the position specified by whence. If whence is set to seek set, seek cur, or seek end, the offset is relative to the start, current position, or end of file. Okay. Okay, cool. So we can just start implementing fseek, which should be pretty easy, right? We have the file. That's the first argument, I think. Yep. Then we have the offset, which is core fic long, and whence, which is a c core fic int, and he returns a integer. Hey guys, how's it going? Pretty good. How are you? Okay, so if we're gonna seek here, we're gonna do different things depending on if we're a like a file with a cursor in it, or standard out. Standard out, I assume, just will return -1. That seems reasonable. Fail. Let's see. Return values. Upon successful completion, these guys return 0, and ftell returns the current offset. Otherwise, negative return is set. -1 is returned. Okay, and earn is set. Well, we won't do that because we're being fucking lazy. And who's gonna care anyway? Who's gonna check earn? Who would do such a thing? Really bad. I'm watching a guy write really unsafe Rust. Hey man, I could see it getting worse, you know? I know we're memeing, but I am of the opinion that unsafe Rust isn't that bad. Right? Because really all you're doing is you're falling back into normal C++ behavior. And sometimes that's easier, you know? I kind of like Rust more for the like type system and like the because like the safe Rust is very nice. The unsafe Rust is a little sketchier, but you get a lot of the benefits, and sometimes unsafe's easier. Okay, so if we're gonna seek, we're going to check whence. So what are seek set, seek end, or seek cur? Like, where do those come from? Seek set. Oh, I just defined these somewhere. Unsafe Rust is worse than C. At least more verbose. Yeah, but like verbosity is like fine. I kind of prefer that. I like the like explicitness that comes from it. I like their like pointer manipulation a little better. Yeah, I don't know. It's like it depends on like what you're optimizing for, I guess. I would argue that the unsafe Rust guarantees that you have to provide are much more difficult. Right? In C you just have like undefined behavior to fall back on, and in Rust you have like unsound, where you're saying like what you've done is like explicitly not allowed, instead of in C where it's like shoot swap. Who knows what'll happen? Okay. So we're gonna check whence. So we're gonna say cursor match whence. And if we have 1, this is seek cur. We have 2 and 3, which go to seek set and seek end. And anything else is fuck you. I guess this is panic invalid whence. What a funny word. And return -1. Yeah, I guess we'll just panic. Fuck it. I don't care. You know, arguably this should just return an error because, you know, you shouldn't just crash every program that does something invalid. But, again, this is a meme. So I don't care. Okay, so if we were going from the end, we're going to say the cursor, we're going to say let file size equal to cursor data lock len. And then we're going to set the position to file size minus offset. Which seems reasonable. And we'll just say offset try into dot expect failed to convert offset to usize. I'm pretty sure that's right. So seek end. It's relative to the end of file. It doesn't really say if it should be positive or negative here, but I'm assuming that a positive offset from the end would go backwards, which makes this reasonable. Then we return 0. If we have seek set, we go from the start. So we just say cursor position is equal to the offset try into dot expect failed to convert offset to usize. And we return 0 in that case. I guess we should just take out all of this, like... Oh, that's fine, actually. Fuck it. I was going to say we should move the return zeros all to one spot, but I don't mind duplicating them here. It's not the end of the world. And seek cur, we have cursor, pause. Now let's think about this. Here, we could have a negative or positive offset. So we could say equals cursor, pause, try into. And we're going to try to convert this into a core FFI, I guess an I64. That's reasonable. And we'll say here expect failed to convert position to I64. So we'll say let pause I is equal to this. Then we'll say that we add the offset to this. We'll say pause I plus offset try. I guess this is just an into. This should always work. Signed long into a signed I64 should always succeed. So I guess we can just say as I64. And we can assign this back to the cursor. So we can say cursor dot pause is equal to this plus this. Try into dot expect failed to convert new position to usize. And probably, like, if you said, like, maybe if you pass in negative a million here, it should just go back to the start of the file. Maybe we should truncate here. But we'll handle that if that happens. And then we return u, or a 0. He doesn't like that generic there. I'm going to still set it here, because I don't like the idea of that just being, like, completely unchecked. And here, I guess I need to set this as usize. No, he doesn't like that. Try fully qualified path. What is it bitching about? Let's look for a more flushed out error message. Type must be known. So when I try setting the type, it doesn't like it, but if I don't... Alright. Right, like if I do try into I32, or usize, I mean. Oh, it still doesn't like that, actually. Oh, what the fuck is this syntax? What the fuck? I've never seen this before, but I guess it does kind of make sense. Jesus. So then I say try into... and then pass in offset. What an awful, awful thing to write down. But we'll live. All right, so I think that might be it. Okay, we'll see if we crash because of like an invalid assumption that we've made there. There's a good chance of that. We forgot to delete the other implementation of fseek, so we'll just go into our fake libc and look for fseek and say you are fully implemented now in Rust. Let's run it. Oh, wow, okay. Strcasecmp unimplemented. All right. So at some point, we also implemented fseek. We can call these done. And now we are implementing strcasecmp. So this is implementing strcasecmp. All right. All right. So what the hell is that? So we have two strings, ignoring the case of the character. Ah, I see. Okay, sure, easy. Easy peasy. So we go into our Rust libc implementation and we look for our string parsing shit, or not parsing, I should say, our like string manipulation guys. So we have strcmp here, and I guess we'll just throw strcasecmp here in the same spot. So we know mangle, so that the C, so like Rust doesn't like change the function name under the hood. We say we want it to be an extern C function what was it? Strcasecmp. And we have S1, which is a const i8, and S2, which is a const i8. And he returns an i32, I assume. I actually didn't check that. Yep. And what's he gonna do? So I guess we could do this two ways. We could like iterate over both pointers and compare the lowercase, or we could just say fuck it, we don't care. We're gonna copy paste this into a new buffer where everything is lowercase and then memcomp. And I think I'm probably gonna do that. So strlen S1, just because that's like slightly easier for my brain to write. So S2 lane is strlen S2. I guess what are we gonna do? We're gonna say. By the way, I saw a bunch of as star const8. Do you know about the existence of pointer cast? I've never heard of that before. What does he do? Cast pointer to a pointer of another type. Is there any like reason that I would want to do this instead? Yeah, is there like any, is this like checked in any way? Oh, yeah. I mean, I guess you could argue that writing cast is like nicer to read. I don't think I see like any real difference there. I'll probably just keep writing as. Unless you have like a reason that I. Oh, because it would do the type deduction for me. Oh, that's interesting. Right, so if I know that something is going to go from i8 to u8, I could just write pointer cast and I have the compiler figure that out for me. I don't like that, I think. I feel like there are like a lot of times, I'm usually on the side of I don't care that much about the type. But in the cases where like this is pointer casting is like the one place where I want to be very fucking sure that the type I'm casting to is the type I mean to cast to. That seems like so. Yeah, I'd be sketched out by just writing .cast and letting it figure it out for me. Okay. So let's create a slice of each of these guys. I guess we're gonna be doing the same thing to both of them. So we might as well like, you could factor this out to a function. I'll just say like let to lowercase is equal to this thing, and he takes in my string, and he gets the length. Then he says cstr from. Oh, I don't actually have to call length in here. I can say cstr from pointer. So now I want to do a like a. Yeah, sure. Cstr from pointer s. Try into. No. I can't remember the APIs. I've already forgotten them all. Cstr. It's been one day, man. So we can say from pointer, we get the pointer. Then we probably convert this into a string to str. And we'll unwrap just for now. This returns a stir, and then can I say like lowercase? What's this guy do? Takes an immutable reference to self, which isn't what I want. I want to like turn him into a string with lowercase. I want to copy him. So string maybe is like where I want to look at. To lowercase returns a string. That's what I want. There we go. Which this comes from core fi. And then I can just say to lowercase s1 and s2 lower is to lowercase s2, and then I can compare these guys. So match s1 lower, compare s2 lower. And we have, what are the types here? He returns, hello, compare. Oh, it doesn't show that. Okay, let's look at the type here then. Ordering. So we return using core, use core comp ordering. There we go. And we have less. Oh, interesting. I guess we can't use like the normal Rust comparison operator because we need to know how different the thing is. If I remember correctly, the return type of strncmp is it has like the distance between the difference at the end as the return value. So I guess we then convert this guy back into a C string. Gross. So can I say core, where does C string come from? Is he from the alloc crate? Yeah, alloc ffi C string. And can I take, yeah, okay. There we go. So I can say, alloc ffi C string new lower s. All right. Okay. Which means that now I can just call strcmp with 2 lowercase s1 and 2 lowercase s2. Which is definitely like a shitty way to implement this. But it was easy for me as pointer. Okay. Cargo check. That compiles. Cargo run. Let's see. Give it a little look-see. And there. Okay, we're at fread unimplemented now. Sick. So we're at 43.24. We're at implementing fread. Cool. So we go back into like the file stuff. Let's look at what fread is supposed to do. So they pass in a pointer, a size of a single element, number of elements, and the file. So they're basically saying like copy this amount of bytes from the file into the pointer. All right. Easy. So here we go. I guess I shouldn't copy paste the whole fseek function, but whatever. We have fread, and he takes in the pointer, which is a mute u8. I guess why did I close this? I need this open still for reference. The size, which is a core ffi c size t. NMEMB, which is a core ffi c size d. And the file. And he returns a core ffi c size t. Unimplemented. We have not done this yet, and we remove the definition from fake libc so that we don't have a double definition. I think maybe I remember seeing that C size t is like not implemented, but cint is, which is odd. Yeah, I don't know. Unstable library feature C size t. I don't understand why that is. Maybe we could look up this issue and they'll tell us. Oh, I see. They want to do this instead. Sure. Okay. They have not decided what they want to do, so I'll just replace these C size t with U size for now. Because I know in this case they'll be the same. Fuck it. You know? Alright. So what are we going to do here? We have let size bytes is equal to size times number of elements. We match file. Sorry, not match file. We match and mute strf to get the cursor. So we have a file with a cursor. We do something. And I guess if we have file standard out, we should just fucking fail. So what's the return value on failure? If an error occurs, the return value is a short item count or 0. All right. Return the number of items. So here we're going to return nm presumably. And I guess the number equals the number of bytes transfers only when size is 1. What happens if we hit the end of a file? I guess if we hit the end of a file, we just can't return that many elements. Okay. So I guess we return size. We'll check. We'll try to reach the end of the file. So here we'll say cursor data lock. We have the data here, and we're going to copy from data from the cursor position to cursor position plus size bytes. But we might not have that much stuff, right? So we need to check either we'll say that the let end position is the cursor position plus size bytes, but we're gonna clamp that to be that, or if the size of the thing is lower, we'll put that as the end. So we'll set data.len here. Then we can say our return value is the end pause minus cursor pause divided by the size. And that floors, that's good. And then in between here, we advance the cursor to the end pause, but only after we copy the data for real. So pointer, copy from, and we copy this from data dot, I guess we take the slice, so we say cursor pause to end pause. And can we just say like as pointer? I guess we just say, we don't even need this. We just say data cursor pause as pointer like this. And we need the length as well. So the length is end pause minus cursor pause. Okay. No method found for as pointer for type U8. So what about this? Okay, I guess I will do something like this. There we go. There we go. Okay, that seems reasonable. So we copy from the data to this guy for this amount of length, and then we set the end, and that's probably good. That seems like a reasonable fread implementation. We'll see if we end up doing something sane. Okay. So that did something. Strncmp unimplemented. So we'll just quickly bang that one out. So we have strncmp is the same as strcomp, but he has a limit to how much he's willing to compare. And have I done other strn things? I did. So I just did a str. Okay, I see. So my strcomp implementation does a memcomp with some extra checking of length. I guess for now, there's probably some sort of like common code we can pull out from here. But I feel like being a lazy fuck. You know? So what we'll do instead is we'll just copy paste the whole implementation and shove an N in here. Which is fucked. Really, all of this stuff is the same. Complete duplication with strcomp. Usually, I would be more willing to clean that up, and I'm almost certain this is going to come back to bite me in the ass later. But I'm willing to take that hit anyways, and I'm just not going to do it because I don't want to. So this is strncmp. Let's see what we get. Ooh, okay. freedoom1.wad doesn't have an iwad or pwad ID. So there's a lot of things that could have gone wrong in there, right? We don't know who he's calling to check that. We also don't know how he's reading the file. We don't know if the buffer reading is working correctly. So we've got a lot of debugging to do. At some point, we implemented strncomp. These guys are both done. And I guess we should kind of expand this buffer a little bit. There we go. Okay. So now let's see where that log would come from. And we know it's wrong, right? Because we've tried launching this free Doom wad before with Doom generic built for Linux, and that worked fine. So there's a lot of, we were just kind of like debug a little bit. So, oops, I just had it. Wad file doesn't have this or this. So he's calling strncmp header identification. So he's reading from the wad file from position 0. I see. Okay. So let's see what we actually got back here. So here we have an identification which is a char4. So can we say what's we'll say char5 identification. It's char identification 5. And we'll copy char identification 4. So we'll say mem copy identification from header.identification equals 0, like this. There we go. So this guy comes from this guy, and we're going to copy 4 bytes. And then we're going to say printf got identification, and we'll print out the string. And maybe it'll say something sane, and maybe it'll say something absolute batshit crazy. Got identification, iwad. Okay. So he's saying he doesn't have an iwad or pwad ID. But we got iwad back. So that means our strncmp implementation is just fucking broken. Which is interesting. So here we can just say comp len is comp len. Oh. hold on. All of these guys, this clamping to n should actually be done on the lengths of the strings that we're using. Because we do some checks if like one is longer than the other, and in this case with strcmp, one is guaranteed to be longer than the other, but we don't care. This also probably is just like completely unsafe, by the way, because our strlen is going to read past the valid memory here until it finds a 0, and then we clamp it to n. We should actually clamp it first. But in another case of I don't give a shit, I don't give a shit. Okay, cool. So that got past that bug. And now we're at calloc unimplemented. Now, I don't remember the difference between malloc, calloc, and I think there's another one. Calloc implements memory, it allocates memory for an array of number of elements of size bytes each and returns a pointer to the allocated memory. The memory is set to 0. So calloc, I think, zeroes the memory and malloc does not. If number of elements or size is 0, then calloc returns either null or a unique pointer value that can be later successfully passed to free. Why? Okay. If the multiplication of number of elements and size would result in an integer overflow, then calloc returns an error. Okay. Okay. So somewhere we have a malloc implementation. And we're going to skip a lot of the error checking that they did because I don't feel like it. And we have calloc was, what was it again? What was their API? Man, calloc, number of elements and size. So number of elements as a usize and size. And we'll say let ret is equal to this guy. And we just have to fucking zero them out. Is there like an alloc zeroed? Like, does this alloc crate have some sort of like calloc analogous thing? Core alloc, where's alloc? This is where I'm looking. Does he have something? He has alloc zeroed, which is essentially what I want. Okay, so we alloc zeroed the layout, and here we just say size times nmemb. And I think that's probably it. Start run. Oh, he's going to complain about duplicate definitions. I have to delete the broken one. Delete that. Cargo run. And let's see where we get to. And at some point, what are we doing here? We fixed strncmp directly after, so that was fine. And at some point, we started implementing calloc, which is done. And now we are at 5800, and we're implementing strncasecmp, which is the same thing that we did for strncmp. But we're gonna do strcasecmp. We're gonna do the same thing. We're gonna copy paste this. And we're gonna say this is now strncasecmp, which also takes in an n, which is a usize. And we have the same to lowercase function, and we just call strncmp to lowercase. And we pass in n. And again, there's like mad duplication here. And we can just factor that out into function, but I don't care enough. I don't care. And we've defined it twice, so we just say strncasecmp. Bump, 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 bump. Okay, do we get anything interesting here? Ooh. Okay. So we're getting a UTF-8 error, which is interesting. So somewhere we're saying from UTF-8, we're converting something into a string, and he's getting angry. So we are going to launch QEMU with a GDB server running. So QEMU has all the information that we need in order to like debug the program in our nice little debugger, I guess. Let me open up my next environment that has GDB in it. Give it a sec. Come on, baby. And what are we looking at here? So I have noticed that in order to get this to work correctly, I do have to hit Control-C occasionally, but that's all right, just to like force an interrupt. And this is in our strncasecmp. There's somewhere where we're not seeing a UTF-8 thing correctly, which is interesting. So we can check. This comes from wchecknum for name. So where does that come from? That's in wwad.c. Check num for name. And this is coming from here. And what is this guy doing? I guess probably somebody's doing some string comparisons. And interesting. So probably there's just like invalid memory being accessed somewhere where like it's not a valid string, which is probably reasonable in this case because he might be just be like reloading from like the WAD file. And maybe he's like trying to find this like spot. He's like looking for the hash table by like iterating over the binary and doing some comparisons. Yeah, and that's causing problems. So I guess in our strcmp stuff, it's actually not really reasonable to expect this to be from UTF-8able, which means I wonder if that we can do 2 ASCII lowercase on a bucket of bytes, which we can. Yeah. So we have slice 2 ASCII lowercase to a vec-u8. So we can just do this whole thing, but instead of doing C-string parsing, we can do we can turn this into bytes instead of 2 bytes, which won't have a problem, and we say 2 ASCII lowercase. And I think that actually everything else will just work there. I think. We'll see. I don't run 1 GB anymore because I think I fixed the bug. Yep, sick. Sick. So it looks like that was good. And now he's complaining 2 upper unimplemented. So let's look at that guy. He takes in a character and converts him into an uppercase character. That's easy. Easy. That seems like kind of string related, so we'll keep it here and we'll just copy paste this and replace the function name with 2 upper. And the value is an I32 to an I32. And we say val to ASCII, val as U8, I guess, to ASCII uppercase as I32. Cool. I guess technically there's probably going to be something wrong here if val is above a like car, like above 255. Oopsies, what am I doing? Man val, what am I talking about? Val man 2 upper. If C is a lowercase letter, blah blah blah. If it's uppercase letter, if C is neither an unsigned car value nor EOF, the behavior of these functions is undefined. Yeah, all right. Okay. We'll delete this guy. And what are we doing here again? I forget. We fixed a bug with something just now. There was a strncasecmp bug. Nope, that's not what it was. What did we just do? Am I high? Oh, it was a strncasecmp bug. And then we implemented 2 upper, which is easy. This is probably too granular, but I just want to keep like a bit like a short list of things that we did so it's easier for me to like sort through stuff later. And we'll cargo run, and we'll see if that broke anything. Hey, look at that. Okay, so this is a really good sign, by the way. What we're seeing here, we're seeing like a real log out of Freedom that is like what Freedom would say. Doom generic is free software covered by the GNU GPL. There is no warranty and no blah blah blah. Well, that just means that, like we've parsed the WAD correctly. which means that like we haven't done anything so fucking stupid that it breaks, which is pretty cool. Pretty cool. So next up on the list is realloc. So say implementing realloc. And I wonder if the alloc crate in Rust has a realloc. So let's just kind of look around here. Oh, nice. Easy. So we don't have to do anything, which is sick. So all we have to do is implement realloc as a function of the alloc crate in Rust. So what's the realloc API? He's got a pointer, which is a... What does this guy want him in? He wants him as a mute u8. And he has a size, which is a usize. And he returns a mute u8. So all we have to do is we still create our layout from size line, and we just call realloc. And... oh, that's interesting. This function forwards the global realloc method of the allocator register with the global allocator attribute if there's one. So what is the layout supposed to be here? Layout must be the same layout that was used to allocate the block of memory, which is actually kind of fucked because we don't have that. We've lost that info kind of. So we have to like extract that from our allocated block. Okay, going back in time. We implemented an allocator back in the day. And how he works is you have this like contiguous block of memory, and he's got like metadata at the start of his block. And this guy basically says like, here's how much memory I have. It's all this. What's this? This is the symbol for that or something. And when we allocate, we just pull from the end and we say like, this is the block. And we stick some more metadata here. And then when we allocate again, we can say, oh, this is the block. And we stick some more metadata here. And that metadata there contains the size. And so I guess in order to implement realloc, since it's saying that the layout has to be the same, we have to add a way to get that information back from a pointer. Which means we look at our allocator class. And basically like what we can do is if we have a pointer to here, we know that there's metadata right before it, and we can just look at that metadata and pull out the size associated with it, essentially. So I think what we're going to do is on our global allocator, we're just going to add a function to it. Maybe we'll say unsafe function get size for allocation. And we'll have a pointer which is a mute u8, and we'll return a usize. Hello, how are you? Good, how are you? Enjoying slowly piping through a bunch of libc functions to get Doom working. Okay. So I guess we have to look at somewhere we have our free implementation must already do this because he needs to know how much memory to reclaim when we free. So that's here. And we have get header pointer from allocated pointer. Nice. And so we can just show this guy in here. And what does this guy have on him? He's a used segment. So we can say header pointer dot and just look at what he has inside. And probably one of these things must be the size. Oh, perfect. Done. Done, done, done. So let's go back over to fake libc. I love it when shit's just like that easy. I thought this was going to be such a pain in the ass, but it's actually just fine. So in our libc Rust implementation, we're going to go back to here, and we're going to say let current size is equal to allocator create allocator get size for allocation. We pass in the pointer. And our layout's going to be made with the current size. And so we pass in, for our realloc, we pass in the pointer, the layout, and the new size that we want to use, which is size that they pass it to us. And we're chilling. I think that will probably work. Maybe. Who fucking knows? We can hope. We can hope. And, you know, if I was doing my due diligence, I would test this in some way, shape, or form. Right? But instead, I'm not doing that. Okay, unsafe preconditions violated. Pointer copy non-overlapping requires that both pointer arguments are aligned and null. Okay, so what's it bitching about? We'll pop up in GDB again. We will do the same thing where we run our GDB script, wait for the QEMU to do something, hit Control-C a couple times, then continue, hit the panic. And so this is actually coming from our realloc implementation. So that's interesting. So I guess he's assuming that where we're going is different. Oh, the source being null pointer is like a really good clue that we fucked something up. Okay, so that's an easy fix. So we just say if pointer is equal 0, or sorry, is null. We need to be readable, of course. We return malloc pointer size. Is that really? Oh, it's just malloc size. Oops, derp derp. Otherwise, we do this fancy realloc shit. Oops, don't want to run in GDB because we already fixed the bug. Well, we think we fixed the bug, and we're not checking because we're being lazy pieces of shit. Hey, look at that! So, we've actually stopped crashing. Now, obviously nothing is happening because we haven't implemented anything, but we finally booted it. That's pretty sick. That's actually super sick. And nothing's like going crazy. So I think that now we can probably start trying to maybe start implementing the Doom generic functions that are like callbacks to like render stuff and see if maybe we can like try to at least render something. Okay, so we're at 112.15 and we're gonna say actually implementing Doom shit. Very, very cool. So this is a good checkpoint. And I don't want to lose shit, so I'm just going to say commit and checkpoint Doom initializes. Big O face. He's surprised. I'm surprised. And now it's actually time to look at Doom generic again and see what do we have to do. Okay. So I wonder if we just, let's start with DG draw frame. That seems the most interesting. Okay, so let's go to main and let's, in fake libc, we have these DG in it. These like, we put them in libc. Clearly this isn't libc, right? But like we pretended it is. And so I'm noticing that they have this like initialization function and he takes in nothing, right? Because his expectation is that you are opening like an X window or something, or like you're opening a window from files, like, sorry, how to say this? You are initializing your application state from the context of DG in it. And he's also expecting that you're probably going to be accessing like static memory in order to set some like globals that you can access again in this other Doom stuff. So I guess we'll probably do something like that here. And we're also, what else do we have to do? We also have to actually call Doom generic tick, which we're not doing. So here what we'll do is we'll just do what they said. We'll put a loop and we'll call Doom generic tick. Okay. And we'll say function Doom generic tick. And he takes in nothing. And maybe what we want to do is we want to start with an implementation for drawing a frame. And for now we'll just say drawing frame. And we should see this being called probably at like rapid pace because here we're just not returning anything. We're just like completely fucking up some of these other functions that would result in like actually waiting for something interesting to happen. So that's okay. And let's just see what happens here. Oopsies, cargo run is what I'm trying to do. So I'm hoping to see some printf spam of it trying to draw frame. And I'm hoping that we can use that to like copy paste them to the frame buffer. But we're not seeing that, which is kind of interesting. There's a good chance that these sleep functions are getting called and we're just returning something like totally fucked. So we'll say here sleeping for %d, pass that in, and here we'll say I guess here we'll just always return 0 or something for now. And we'll say printf returning 0, just so that we have some logs that happened. Here, I guess we'll return 0, and we'll say printf dg get key. And this guy doesn't have to do anything. So now at least we'll get a clue is like, have we done something that's causing it to get stuck? Right? Let's try that. It's possible that we're actually not finishing and we're getting stuck in some infinite loop somewhere. So what would be interesting is if we run this in GDB, we can start, oopsies, start gdb-x run.gdb. What the hell? Why? I wonder why that wasn't tab completing. And we can just wait for that part in the code, and we can control C and see where we are. So we're in this while true in I error. Aha! So this log that happened is actually going to... I see, we actually have to implement this. So we didn't finish initializing it. I thought we did. So wget num for name, stcfm33 not found, and that's pretty reasonable. That seems kind of fucked. I wrote a naive strcasecmp implementation with allocation. I can give it to you if you want. I guess it would be rude to not look at it at this point, right? If you're going through that effort and I was just like, fuck it. You'd be like, damn, I don't want to contribute anymore. Yeah, so I'll take a look. I think it probably doesn't matter, but I mean, you can be rude. No, it's okay. I think it's interesting to take a look. I was more like just too lazy to do it. So if I look at what you have and it looks decent, then yeah, why not? Oh, and you've even got some little tests in here. Very nice, very nice. Okay, so we have strcmp while unsafe. Oh, interesting. I didn't know you could throw an unsafe there. What the fuck am I looking at? Oh shit! Sorry, not judging you at all. Like, I'm sorry, that wasn't a what the fuck did you write? This is more like I didn't know that this was like safe for us code. But I see. So the while loop is like while block 1, block 2, and the block 1 is like the condition, and you're just like doing other stuff in the condition. That's crazy. I've never seen that before, but it makes sense. Yeah. That's crazy. And so what's going on here? You say C1 is equal to S1, F C1 S2. Oh, I see. So you're doing some sort of like, your condition is blocked by the function, and then you're passing in, I assume, different functions based off of... Yeah, that's kind of sick. Yeah, that's kind of clever. Very clever. Yeah, that's pretty cool. Pretty cool. So this covers strcmp and strcasecmp. And then I would guess that I could probably implement strncmp with something very similar by having like a limiter function. Like maybe I pass in not only S1 and S2. I guess no, you could store like the length as a member of the lambda. Sorry, lambda's a C++ language word. As a member of the closure. And you could then check that as well. Yeah, that's clever. That's sick. You do too much Rust. Yeah, sometimes you can tell. You can tell like who's a C++, like coming from another language and who's like deep in the Rust sauce based off of like how many generics you're using and shit like that. Yeah, I like that. I like this though. Okay. So let's yoink this. Next time I'll write some Lisp into it. Okay. Sorry, let's shove this into strcmp. Here it is. And we'll destroy my old strcmp and strcasecmp functions. And while we're here, we might as well fix strncmp. So strncmp is going to do the same thing. But he's also going to check n. So he's going to say oops, wrong one, this guy. So we'll say we're going to move in n, and we're going to say if where we are is greater than n. So I guess one of the things that we have to pass into our strcmp now is also our position in the string. So here we'll just pass in position, and here we'll throw in let position is equal to 0, pause plus equals 1, and here we have to say that we take in a usize, I guess. Cool. And these guys now have to take in, say, I don't give a shit about our position. And on the end side, we take in pause. And we say, what if pause is greater than n, return 0 something, return something. But I think that here we have to check who's longer. So if position is greater than n, oh, I see. If position is greater than n, we return 0, I guess. Oh, this guy, so this gets a little crazier. This guy needs to return not only... Oh, actually, I wonder if this condition was right with what you did before, by the way. You're not null checking string 2. I'm gonna say, while I appreciate the addition and I agree that this would end up with something better, I'm not 100% convinced, and now I'm having to think about it, and I don't want to think. So, while I appreciate it, I think I'm just gonna leave it as it was. Apologies, but appreciate the contribution. Okay, sorry, let's jump back into the Doom shit. So we were in a backtrace where wGetNum for name was not implemented correctly. So let's see in wwad, what is that guy doing? So getnum for name. So he's calling wcheckNum for name, and this guy is just not doing the right. He's getting something wrong. You're still null checking S2 and S1. Where are you null checking S2? Here I'm seeing C1 is equal to S1. Here, oh, because if S2 is, because here you're assuming that if S2 is not equal to S1. Yeah. You're right. I guess I could have also checked your test cases, and that would be pretty clear that you were doing the right thing. You are correct. But I still was having to think. And I'm trying to dodge that today, so I am gonna just keep leaving it as this. But I do agree that what you had is better. Okay. w check num for name. So what's this guy doing? Jesus Christ. Okay, so we have a name. We're looking for lump name hash. Didn't write it myself, can't understand it. No, I think it's... yeah. You know how it is sometimes. Okay, so get num for name. What is this guy doing? He's looking up the name in a hash table. And someone's complaining that we don't have it. So let's maybe look at this first. strcfn33 not found. So who's logging that? This guy. That's not really helpful. So this guy's returning something less than 0 for the given name. So there's a couple things that could be happening here. Maybe the name that it's passing in is complete garbo, right? strcfn33 sounds like garbage, right? What does that even mean? So we can look at where this is coming from. This is coming from w cache lump name and wwad.c 430. And this is coming from hu init, which is an hu stuff.c at line 298. Oopsies. hu stuff.c 298. Oh, okay. So okay. So that's good. strcfn33. strcfn33. So there's a chance that my in fact, I know that my precision formatting is wrong here. So what's supposed to happen if I log this? I probably just am doing the wrong thing here, almost certainly. So let's just try this. So if I go into my test.c, I guess it's probably open here. And I just try to log. Oops, shit. Where was I? This here. Paste this guy here. And just punch in like 4. What's supposed to happen? So gcc-test.c. Oops. test.c. Oh, fuck. I overwrote the file by mistake. So we'll just save it again. Run test. So we get 004. So what if I do 03D? Is that not the same thing? I thought that... Interesting. I thought precision specifiers, like the period, only handled stuff after the dot. But I guess it's the width of the entire string. I see. So in back to our printf stuff, we will check. Where is this? In libc. We have our printf stuff. And somewhere we do the like precision thing here. So here we've parsed the precision. We inject the precision into our printf format specifier thing. But we never check it, right? We just don't use it because we were like, fuck it. Sweep swap. But it's clearly important. So what happens is somewhere when someone pushes an argument to us, we like write that directly into the printf output. And so in the case of any of these guys, really, we should be prefixing our integers with the number of zeros to get to the precision. So how can we do that? In Rust, probably there's like an int to string function of some form. I'm assuming. I don't actually know. ToString. And is there like a way to like ToString but like with the padded zeros? I could do the padding myself, but it just feels like the type of thing that like would already exist. Like maybe in the like formatter. Right? Like this seems like the kind of guy that you could maybe pad integral. Here, this is exactly what I'm looking for, right? Performs the correct padding for an integer which has already been emitted into a string. Right string, right format, fill, align. Right, like this is like the thing that you can use to specify your own custom formats, and it just seems like the type of thing that would have what we need. But maybe this is too complex to pull that off. What is, like, when it says pad integral, is it just implemented directly in here? Or is it implemented somewhere that we can pull out? Yeah, it's just straight in here. All right. Fuck it. So for each of these, we need to pad it with precision. Which means that we have to convert it to a string, check the length, and then pad the zeros in up front. So here we can say, I guess we'll still do these writes, but to a normal string, and then we'll pad it manually after. So we'll say let's think. We'll say arg as const32, and we'll say string to string. No, I guess we say to string. Is that how you do this? And we'll say let arg s is equal to this. No method to string found for type 32 i32. I think because we have to use the alloc crates string to string. Okay. Then we can pad this. So we can say while arg s len is less than I guess we have to check the precision. So we'll say, I guess we'll write a function here. We'll say left pad this argument string with the character 0 with self dot, no, not self, the specifier precision. And then we'll write that guy here. Cool. And then we can do that for all of these. Actually, probably what I want. Yeah, that seems reasonable. Then for these guys, we're just gonna get a little tricky here. And for the hex string, we're gonna say format. We're gonna copy what we already did here. We're gonna call format to make the hex string. Like this. And for octal, we'll do the same thing. Which is octal, sorry, alloc format, probably I need to say. Yeah. And then all of these guys will look the same for the right thing, which is like this. Boom, boom. Cool. Cool. So now we just have to make the left pad function. So here we'll just say somewhere function left pad. We take in s, which is a string. We have the value that we want to pad it with. I guess we'll make that a char instead of a byte char, like a U8. So we'll say the val is a char and the length is a usize. And we return a string. This is unimplemented, just because I want to see that this still compiles correctly. And I guess the length is an option usize. Okay. So, and I maybe, what are these guys complaining about now? Arguments as function are incorrect. Why? Why? Oh, because there are U32s, I see. So we'll just make this an option U32. Okay. Cool. So we can say, oh, we're not importing string, so we say import string. let's take a look. So we can say let length is equal to match length. And if we have some v, we use the v, and if we have none, we just return the string directly. Right? We have nothing to do. Otherwise, we have a length that we want to pad to, and we can just say while s.len is, we can calculate the pad that we need. So let extra cars is equal to len. I guess we say if length is less than s.len, we also just return s. And I guess we can say less than or equal to. And so now we're guaranteed that length is bigger. So then we can say extra cars is len minus s.len as usize. Okay, we should do that here as well, as usize. And we just pad with the extra characters. So can we say like s, is there like a left pad? No, we just have to, is there like an s repeat, val repeat, str repeat. That's probably what I want. So we can say, can I convert a car to a string? Does this, or how do I like repeat a car a certain amount of times? Repeat, rust, repeat, character. Jesus. There's stir repeat, but that takes in a string, not a car. But I guess we'll see. What happens if I can? Maybe Rust will tell me about why this is bad. And then we'll say format. We have the repeated thing and then the thing that we originally started with, and we are passing in that guy, and we return this. Boom. This is val, sorry. And arguments to this are incorrect. Can I like Rust convert car to stir? Is that like something I'm allowed to do? I know like converting isn't the right thing. Oh, there's just a toString. Yeah, sure. All right. So I think that should work now. And so we should see now that if when we run this, we should get a key that has a 3-digit string. Oh, sick. Okay, so we did the fact that we are now in this loop of stuff means that we passed that like that crash that we were hitting earlier, and we are now hitting these like doom functions in our event loop, which is pretty sick. So I guess somewhere we were saying fix padding on precision formatted strings. And now we're back on implementing doom shit again. Okay, so this is at 38:40. And it would be really cool if we could at least get to the point at the end of the stream where we're seeing something on the screen. That's like really like the goal, I think. So what does that look like? It looks like in our Doom stuff, it probably needs the concept of time to work correctly. So let's try to implement those guys. So we have fake libc, and we have this like Doom generic shit. DG init, we can probably ignore. What we're probably gonna have to do is we're probably gonna have to get access to our kernel from within these like functions with no arguments passed to them. And so probably what we're gonna have to do is we're probably gonna have to stick our kernel like in static namespace somehow. So we can say static kernel is a once cell kernel. Like, is that legal? And somewhere else we need to use core cell once cell. And almost certainly it's going to bitch about it to me. This cannot be shared between threads safely. Okay, so kernel. I think that we can probably safely say impl sync for kernel. I'm pretty sure. We'll see. I mean, I don't really care also, right? We can just lie. Oh, maybe I need send as well. Oh, he still doesn't like that. Okay, so maybe our once cell has to be mutex locked, which is fine. So we'll just have spin lock once cell kernel. All right, sure. So we'll just serialize it all. I don't give a shit. We don't have spin lock in here, so we'll just pull it in. So somewhere we have util spin lock spin lock. He's got to be capitalized. And here we say equals once cell new. So why doesn't he like that? I thought that was equal. Oh, because I need spin lock new once cell new. Of course, of course. So the only real reason to put this behind a lock is to make the type system happy with this. Really, we know we're not going to need like synchronous behavior here, but we might as well just throw it behind there just to make the types happy. Okay, so now what we're going to do is we're just going to like remove all this shit, right? We're not doing anything but Doom in this OS. I don't even want to do jack shit. And we're going to take some of these like libc functions and start implementing them here. So what we can do is we can say no mangle pub unsafe extern c function dg get ticks ms. And this has to actually like do something. So we'll say this does like a kernel lock and he's going to look at the time. So in here, I think our kernel has a monotonic time thing in him. Monotonic time. And he's just going to say get. No field monotonic time on spinlock guard once cell kernel. Oh, oops. This has to be get or init with a function that says kernel init. Fuck. We're going to assume that he's available here. And here we're going to say that instead of assigning to this kernel, we're going to assign to the global one. So we'll say let kernel is kernel lock. And can we just like, is there just like a straight init? There's only get or init. And here we will just do this. So instead of initializing a local kernel, we stick it in the global. Cool. So now when we're in here, we should be able to lock the kernel, grab it, and get access to the monotonic time. And I guess here we should return the time as a float in milliseconds, which I think, what do they want? Do they want it as an int? Get ticks milliseconds is a U32. So here, we just need to convert this. So we say, I guess we'll pull up the monotonic time like this. So say let kernel is equal to kernel lock dot get. I guess kernel lock. And then we say kernel dot get. I'm just trying to like extend some lifetimes here with this double assignment. And then we can say this should be unwrap. And then we could say the tick is the kernel dot monotonic time dot get, and we'll say let tick frequency is kernel monotonic time tick freak, because these are not going to happen once per second. These are going to happen like some rate. And so tick freak is in ticks per second, and if we want the ticks per millisecond, we say ticks per millisecond converts to ticks per millisecond by multiplying by 1,000. And if we want milliseconds, we have to divide by that. So then we have to do 1 over ticks per milliseconds to get milliseconds back. So we'll do 1 over 1.0 over sorry. We also have to multiply this by the tick somehow. So we're gonna say tick. Sorry, let's do the Unix versions here. We have ticks per sec. We're gonna divide that by 1. So we're gonna say we say 1 over ticks per second goes to seconds per tick. Then we multiply that with ticks to get seconds. Then we multiply that by 1,000 to get milliseconds. There we go. That's it. So we say ticks over tick frequency. Tick as f32 divided over tick frequency. And then we do 1.0 over that times 1,000. I'm pretty sure that gives us milliseconds. Units are so hard. Let's just double check this. So 1 over, oh, what did we write here? We wrote 1 over tick freak times tick, which is the same thing, but maybe I like that better. Yeah, that seems, that's easier for me to think about. So this is seconds per tick. And then we have tick. And this is seconds to milliseconds. Okay. Okay. Jeez. It's so hard. And then we just have to convert that to an U32. So we say ticks MSF as U32. Okay? We'll make it so that sleep MS just does nothing. That's fine. We'll remove this print because I think when we print too quickly, we stack overflow and crash. And let's see what that does. Cargo run. Hopefully we start to see some like drawing frames in here. Yeah, okay, sick. So now they're drawing frames, and all we have to do for a draw frame is copy into the frame buffer. So here we can say dg draw frame. He returns nothing. And what's he do? He still does the same shit where he gets the kernel, but what's he gonna do instead? So presumably we have to get the frame from somewhere, right? So where does the frame buffer come from? So let's look at like the SDL, like where do we want to look? Xlib implementation seems reasonable. So he looks at the display, blah, blah, blah. Where's the like put image? He puts the S display, S window, S image. So S image, what does he do with this? No, that's not it. Like, Doom must have drawn to somewhere, right? And so like who tells Doom to draw to that spot? So in DG init, does he call any like Doom functions? No? Am I high? Shouldn't he have to initialize like the Doom system with somewhere to draw? Doom generic res X, Doom generic res Y. Oh, thank you for reading docs that I didn't read. So you're saying that they wrote in their README, probably, that there is a DG screen buffer that I can just copy from. It does say that. And so probably in their Yeah. Nice. Good call. So here in my Rust side, I have to say, hey, there's a static DG screen buffer, which is a mutable pointer to U32. And in my draw frame, I just have to copy that into my screen. So they have res x, res y. Where do these come from? Doom generic.h. Doom generic.h, probably. Res x and res y, 640 by 400, which is brilliant. That fits in my screen, so I don't have to fucking think about that. So we'll say let x res x equals 640, res y is 400. And let's think about this. We have a frame buffer. So we just do the same shit here where we get the kernel, we look at the frame buffer. And what APIs do we have on here again? It's been a while. Frame buffer. So we have a way to basically paint something with a specific pixel color, but we have no way to just like copy a texture in, which is essentially what we're doing here, right? We kind of want to walk the texture and copy it in. So we're going to cheat again because I am being lazy. We're going to make this public, and we're going to say kernel.info, or sorry, frame buffer. We have this frame buffer info, and in here, one of the many things that we should have is just the address. And I guess we need to know the format of the Doom generic pixel, right? Because here we're kind of assuming RGB32. And we should check if the Doom generic buffer is the same thing. So he has somewhere, where are you at, boy? DG screen buffer. But like, come on, you tell me what it is, man. I guess I should never critique another open source project because like, I mean, who's he? Like, I don't give a shit. Like, he can do whatever he wants, but I wish that I knew how many bits, like it said the color format there. But it's okay, we can find it. It's easy to find, probably. So let's see. Who writes this guy? Line out. DG screen buffer. Okay, so he has... Ooh, CMap to FB. So what does this look like? FB, so what's he writing here? CRGB. Okay. And then he's packing his thing as red, green, and blue with offsets. Sick. And bits per pixel. Okay, this is solid. This is actually like almost exactly what I have. So where is SFB? Can I like modify this? Who sets this guy? Init graphics. Oh, boom. This is sick. Okay, red. Oh, this is perfect. This is actually perfect. This is exactly what we have, I think. So I think I can probably just like straight mem copy him in. Because this is a 32-bit bits per pixel 32, which is what we have. And if it's like slightly off, then we can just account for that, but that's fine. Okay. Hey, worst case, it just looks wrong. That's what I'm thinking, right? If it's, well, I was concerned that at least with 32 bits, it will at least be close. Well, we should see something like semi-reasonable. Okay, so in our main, we can just get the info, and we can say, we probably want to like iterate lines, so we can say for y in 0 res y. We will copy in one line at a time. So we'll say let line start is equal to this pointer that we have in our frame buffer, which has adder. And then we just say line start. For each line, we're going to add in the pitch of the line. So we're going to add in frame buffer info. Oh god. Kernel frame buffer info pitch, right? Because, okay, somebody, you know, you guys aren't me. You don't remember exactly what I did like a month ago. So the way this like kind of works is grub, the bootloader, is going to initialize our frame buffer for us. And we ask it to initialize it in like a specific way. So essentially we're going to get like this like, what is essentially a linear chunk of memory, right? And this is going to be batched into like sections of like pitch length. Maybe it's better to draw this as a window like this. So this is, say this is your screen. Now this is like backed by some chunk of memory, and what might happen is if my memory, if I have like a memory that's like linear memory like this, you would kind of assume that if you were to like draw a line here, this might be the start of the next line. But instead what might happen is, because there might be like alignment reasons, or like maybe like the window, the monitor itself is like has more memory associated with it or something, you might actually have like a width and a pitch that are different. So what I'm doing is I'm going to iterate over like the linear memory would be like if I drew lines like this and kind of like stapled here to here. So there's like a bunch of like garbage here, so we have to like make sure that it might not match the width essentially. We might have some like dead space that we have to fill. And so what we're doing here is we're saying, well, we're going to iterate over lines by line, and we're going to say line start is every line we're going to add to the pitch. Are you using multi-boot 2 or multi-boot 1? Multi-boot 2. We had to upgrade to multi-boot 2 for something. I don't remember why. Let's see. Multi-boot. Oh, for multi-core, we had to upgrade to multi-boot 2. Okay. So yeah, so we have to iterate line by line, and for each line we increment by pitch, where pitch is like the plus the garbage. Then we're just going to copy in what we have in DG whatever, DG screen buffer. So we'll say let from pointer is equal to GG screen buffer as mute U8. Because he's a mute 32, but we're just going to convert him like this, and we're going to say we have to do a couple casts here. Line start, copy from pointer res x. Right, so we're going to copy 640 pixels, but the pixels are 32 bits long, so we're going to have to multiply by 4. And I think other than that, we're good. And so now we're just going to say that we're going to increment our from pointer is equal to from pointer add res x, because I think that there's no pitch on the Doom side. So the Doom side, we're going to iterate by chunks of 640. On our side, we're going to iterate by chunks of like pitch, and then we're going to just copy from one to the other and hope that that works. We'll find out. What's he bitching about? He's mad because we have 2 implementations of draw frame, because we have one on our C side, which we can just get out of there. We don't need him anymore. And let's see if we draw something. Come on. Hey! That's something! That was pretty close! Look at that! We're seeing shit happen! Look! That's clearly fucking broken, right? I guess their pixel packing is not what I thought, or the resolution is too wide. Right, you were seeing like a pretty clear repeating pattern, right? A quarter way in. The colors look about right though, right? We see the red text. Someone's saying that I forgot to multiply by 4 for the from pointer, and you are just, yeah, big correct there. And maybe we need to increment the pitch by that as well, but we'll see. Good catch, good catch. Come on, baby. Hey, look at that. Look at that. That's so sick. Okay. I'm pretty happy with that. God, that's so cool. We did it, guys. We finally made it. Now, obviously there's a bunch of stuff that we might not have done yet. there's a lot of like unimplemented functions still in our fake libc. We don't have like no input is handled right now. But like we see something that's moving at like a pretty reasonable frame rate and looks like the right colors. So pretty happy with that. We're at like the 2-hour mark perfectly. So this is like just in time. And so I think we'll call it a day there. And we'll come back tomorrow and try to kind of tie this off. There's a couple more pieces left here. Like one is like input. Input should be pretty easy, like in terms of like supporting keyboard. But I think that there's like a little bit of extra stuff for mouse input. It looks like wasn't easily supported in there. So we'll probably try to hook that up too. And that might not be long enough for like a full stream. So I think that I've also noticed some bugs with mouse handling input. So we can use that as an excuse to debug those as well. So we'll come back tomorrow for that. Yeah, cool. Thanks for watching. If you like what you saw, I stream most days on Twitch at around like 1 or 2 Pacific time, somewhere between there. And I like to go for like 1 or 2 hours. If you miss me live, there's a YouTube channel that's linked in the Twitch description, and you can use that to catch up. Videos go up there pretty soon after. And for the regular case, in this case, it's like a little bit different because this is like kind of scratch code for a meme. But when we have like real functions, real features implemented that we want to stick around, those will eventually end up on GitHub in like a cleaned up format. If you're watching on YouTube and you want to say hi on Twitch, there's a Twitch link in the YouTube description, and you can come by, say hi, chat, whatever. Yeah, thanks for watching. Catch you guys on the next one. Bye!